Hey everyone, thank you for joining me today for this critical discussion on ransomware readiness, backup and recovery in the cloud. My name is Srihari Pakalapati, and I'm a principal cloud and security architect currently working for Trader Interactive with over 15 years of unique experience across cloud security, vulnerability engineering, DevSecOps, and cloud solutions architecture. And then coming to this, what is ransomware? So ransomware refers to a business model that in a wide range of associated technologies that unauthorized users to use to export money from entities. Unauthorized users or system vulnerabilities to access data and then restrict the rightful owner from accessing. So ransomware encrypts your data, making it inaccessible until a ransom is paid. Attackers often demand payment in cryptocurrency. So before we dive in, let's start with some context. Ransomware attacks have exploded in recent years. It's hard to turn on the news without seeing another company getting hit. So according to the Sophos 2024 report, 59% of the organizations surveyed, they were done out of 5,000 organizations, were hit by ransomware in the past year. That's just the attacks that were reported. Many incidents go unreported due to various reasons like brand reputation, stock price impact, other reasons. So if you look at the report, 94% of victims said attackers targeted their backups. So that means it's just not that the attackers are targeting for your primary data, but also the backup infrastructure. So 32% of the victims whose data was encrypted also had data stolen. So that means once your backups are compromised or your data is compromised, they will extract the data, exfiltration of data, so that they can host you as hostage for the data. And then the attacks, 70% of attacks result in data encryption. So that means once they exfiltrated the data out of the organization or network, they encrypt the data. And after that, so organizations whose attacks began with exploitation of unpatched vulnerability report considerably more severe outcomes than those were with the attack started with compromised credentials. So based on these statistics, the average initial ransom demand that was being demanded is $2 million. And then 98% of the organizations that were attacked were recovered their encrypted data. So either by paying the ransom or from those backups. But lately, the trend is slowly started shifting towards the restoration is happening from the backups that they have, which is a good sign. And then the next one is the recovery. So the average recovery cost is $2.7 million. So excluding ransom payment. So 30% of these organizations had more than a month to recover. So that means once they are compromised, it's either due to lack of backups or lack of readiness or playbooks. There's no proper incident management. So all these, due to these factors, it can take more than a month to recover from those incidents. That means once your applications are down or your organization applications are down, it can take 30 days to recover. That's a lot. In some scenarios, it can go beyond that. Today's objective is straightforward but crucial to ensure you understand the critical nature of disaster recovery planning in the context of modern ransomware threats. We will explore cutting-edge backup strategies, battle-tested techniques, zero-trust architectures, and automated recovery workflows, transforming your backup infrastructure from a potential liability into your strongest security asset. So let's take a look at the ransomware landscape. Ransomware is not a static problem. The ransomware landscape is constantly evolving. You are playing chess with thinking humans on the other side who can quickly adapt. Just in the last year, we have seen threat actors significantly evolve their tools, techniques, and procedures like ransomware as a service, including AI based sophisticated techniques. For example, we have witnessed the rise of intermittent encryption, so which speeds up the encryption process and evades the detection. Ransomware operations have become almost industrialized, with the different specialized groups handling different parts of the attack, from initial incursion to negotiation specialists. Threat actor objectives are expanding beyond money. So some groups are now taking sides in geopolitical conflicts. Meanwhile, cyber insurance is falling short. Major global underwriters are reducing or refusing ransomware coverage, adding sublimits to policies. And we have seen cases where payouts were denied by classifying ransomware as an act of war. And attackers usually gain that attack pattern is established and repeating across organizations. So usually it happens like an event of chain, a chain of events. So attackers gain initial access through infection vectors, including like phishing emails, in malicious attachments, drive-by downloads, vulnerabilities in remote access protocols, exploited vulnerabilities both in operating systems or in language frameworks. So compromised credentials, flawed public-facing applications, something like S3, or weaker authentication setup. So from there, they can get into your infrastructure, cloud infrastructure, and cloud storage. So they do the discovery actions, and then they can go to the next state of events, like a data destruction, data exfiltration, data encryption. So these can impact a lot of ways. So they establish a persistence, they move laterally throughout the network, they exfiltrate data before encrypting it, they deploy encryption and demand runs. So sometimes in usual cases, some of these organizations, the attackers were so persistent that they can stay there for months, like 2 to 3 months. They will do the slowly these operations in the back end without any detection. So once they hold all the footprint, what they want, that's when they'll start encryption process. And here is what the particularly concerning. In most organizations, making it's much easier to block inbound traffic than outbound traffic. So making data exfiltration a significant risk. Because before they do the encryption, usually they try to exfiltrate your data so that they'll try to demand or they'll try to do the extortion. They'll try to do the extortion demand, telling the sensitive data to expose it public. And that's what those are like the chain of events that it can happen. So coming to attack scenarios are a little bit different, like the same little bit on similar way that what we just talked about. So like data encryption. So usually attackers lock down critical data and files, making it inaccessible. And then system disruption. So they try to halt all your systems, like operational systems or rendered unusable, disrupt critical systems and services. So that means you cannot operate anything inside your organization related to infrastructure, IT infrastructure. Data exfiltration is a sensitive data is stolen before encryption. So they try to have this data before encryption so that they can demand ransom payments or threats saying that this will be released to public. And then the next one is the extortion demands. So they demand ransom payments to restore access with threats of public data leaks. Like you pay the ransom through the cryptocurrency, then they'll tell you to give the key. They'll promise you that. It never goes that way. So the common pitfalls in ransomware response is when an attack happens, organizations often make critical mistakes that compound the damage. So these areas are a little bit wider here. So there are inadequate crisis communication. So that means too often organizations lack a clear crisis communication plan. In the midst of an attack, you need to know exactly who's involved and who takes specific actions. According to a PwC study, PricewaterhouseCoopers study, 69% of organizations that successfully navigated a ransomware attack had documented and practiced communication plans. So having that practice and documentation will really help you when you need it. And there is another one is insufficient logging and monitoring. So usually security teams depend on these. They need access to logs to build an incident response timelines. That's how they know when the attacker entered into the network or when the data has been compromised. But many organizations discover too late that their logging was inadequate. So research reports found that organizations with proper security monitoring detected breaches 74 days faster on average than those without. And the next one is unprepared for ransom decisions. So many crucial questions arise when there is an incident happen. Who can authorize a ransom payment? Has your board approved such payments? Do you have cryptocurrency available? Are there legal implications? The US Treasury Department has sanctioned several ransomware groups, making payments to them potentially illegal. So making this option completely off the table. And then underestimating recovery times. So most of these organizations often assume recovery will be quick, but but comprehensive incident response takes a lot of time, sometimes without any preparations. So IBM's cost of data breach report indicates that the average time to identify and contain a breach is 277 days. That's overnight. So those are like the common pitfalls in ransomware response. So without that proper response, you will be doomed when there is a real incident happens. And then there are backup failures happens because this is perhaps the most devastating pitfall. So many organizations discover too late that their backups are either compromised or encrypted, incomplete, or too outdated to be useful, inaccessible when needed most, unable to be restored in a timely manner. So here the key takeaway, it's not if, but when organizations should be ready for ransomware situations. So how do you do this recovery planning and the recovery planning considerations or strategy? When planning your recovery strategy, 4 key factors will impact both effectiveness and cost. So one is scope. This tells you how much data needs protection. And then RPO, so recovery point objective. How much data can you afford to recreate or lose? And the third one is RTO, recovery time objective. So how quickly must you recover? What is the cost of downtime? And then the last one is copies. So how many backup copies do you need to maintain? So different workloads will have different requirements. And then these things can be derived if in order to do the recovery strategy, or you want to do the optimize that recovery strategy, the critical thing that you need to do is the data classification. So you need to make sure you have your organization has a data classification already done or defined. Take a step back, like one step back to, like I did mention RPO and RTO as part of the strategy. These are critical in defining what kind of strategy that you want to design. And to do that, you need to define these, and you will define based on the data classification. So when it comes to RPO and RTO, how much data can you afford to recreate or lose when a disaster happens? Like suppose the disaster happened a couple of days back. Can you withstand these 2 days downtime or 2 days loss of data? That's called RPO. And then the other one is how quickly must you recover? What is the cost of downtime? That means how long you can afford to lose your downtime. So that means your whole application is down. Like how long you can afford that? So can you afford 1 hour? Can you afford 8 hours? Can you afford 10 hours? So that's RTO. And then coming back to the data classification. So that's the critical thing in order to discover your RPO, RTO, or the scope or the copies. So how do you decide the criticality? So if you look at here, you need to understand what type of data you have and who owns it. And if it is critical for your business, what does actually critical means? So does it impact your customer? Does it impact your business revenue? So how do you determine the criticality of data criticality or data classification? So you do this by simple flowchart here. So you can define, is your data operating? So operational, that means your data is being operated or not. So that means assume your data is completely lost. So what do you do? So if the business was to move forward without the data, or would there be an impact? If there will be an impact, that means, can the data be recreated? If you cannot recreate, that means that is your true critical data. And then you should go for a backup plan. If the data is not that, it can be recreated. So that means it takes how long it will take to recreate the data. Can it take in minutes or hours? So based on that, further guidance is required. And if the data where there would be impact, if there is no impact, then it is not a critical data. So that's how you simply follow the chart and determine what kind of critical data that you have. So first you need to know your data. And then there's a different tiers and different RPO and RTOs defined for each of these kind of, depending on their data classification. Generally, the mission critical systems, these are like required true disaster recovery solutions, typically highest cost tier, like example, payment processing, critical infrastructure, which typically they have RPO and RTO within less than 10 minutes. So that means without these systems, you will be losing a lot of money. And the next one is business critical systems. These require robust disaster recovery solutions. Examples like ERP systems or customer facing applications. And generally these RPO, RTOs for these type of business critical systems is less than 1 hour. And the next kind of thing is business operational systems. Like these are can be often use standard backup solutions. The RPO and RTO is like less than 8 hours. Like examples like internal collaboration tools, reporting systems. So even if they are down, the impact is not much for any customer or revenue generation. And the last but not least is administrative systems. These are like standard. You can go for standard backup solutions that are sufficient, like example, HR systems or documentation repositories, something like that. So these typically the RPO and RTO fall in 24 to 48 hours. So depending on these that you define RTO and RTO and data classification and critical systems, you can design your strategy against your resilience. So how resilient you want to set up. So if you take this one, this slide gives you 3 scenarios. Like one is a backup scenario, how much it costs, and what are the RTO and RPO, and then the disaster recovery. So what are the typical RPO and RTOs? Remember that every minute of downtime costs money. So according to Gartner, the average cost of IT downtime is $5,600 per minute. So which extrapolates to over 300,000 per hour. This will help you determine what kind of application or what kind of data that you have and what kind of strategy that you want to build, a resilient strategy. Like you want to go for backups with RPO and RTO within hours, or you want to go with the disaster recovery, which has RPO and RTO within seconds and minutes, or you can go for RPO or RTO in real time, near real time, literally within seconds. Like basically this is a high availability. So this high availability is designed in the phase of architecture, operational mechanisms. That's when you design these things. Obviously, the cost association will be something respect to each of these strategies. And then coming to the next part, which is my favorite thing. So let's talk about a functional element of ransomware readiness. So the 32110 backup rule. This is an evolution of the traditional 3-2-1 backup strategy. So designed specifically to enhance data protection against modern threats like ransomware while ensuring reliable. So back in the days when I used to work on the infrastructure, which is hosted in the on-premise, this used to be a standard now, like 3-2-1. And then now everything is cloud. Most of the organizations moving towards cloud. And it's imperative that a lot of the attacks that are also happening in the same space. Now there's a need to evolve that traditional rule to customize or adapt for the new threats, modern threats like ransomware. So let's go a little more in detail on this. What is 32110 backup rule is? So the starting one, three. So maintain 3 copies of your data. So basically it says you need to maintain 3 copies of data, including your production. So 1 primary copy, which is a production, and 2 backup copies. This redundancy ensures that even if 1 or 2 copies are compromised, you will have a reliable backup. And the next is number 2. So use 2 different type of storage media. Store backups on at least 2 different storage types. So traditionally it should be like hard drives, SSDs, tapes. Now with the cloud, you can do with cloud storages like block storage or object storage based on your data classification or the data type. This diversification minimizes the risk of simultaneous failures due to hardware or software issues. And the next is 1. So keep 1 copy offsite. So at least 1 backup should be stored in a separate location, such as a remote facility or in the cloud. This protects against local disasters like fires or floods that could destroy all on-premises data. Or if it is the cloud, then the cloud does have regions and availability zones. They can hit with these natural disasters like fires or floods or earthquakes. So you need to be prepared for that. And then the next one is store 1 copy offline or make it immutable. So this part is a new in adoption of ransomware readiness or ransomware protection. You need to make it immutable. So this is crucial for ransomware protection. So 1 backup must be either offline, like air-gapped, completely disconnected from networks, making it inaccessible to ransomware. And then immutable, so cannot be altered or deleted even by the administrators, adding an additional layer of security. And the last part is 0. So the 0 represents ensured 0 backup errors through regular verification. Regular test that backups are error-free and can be successfully restored. According to a Veeam survey, 40% of recovery attempts fail, and 77% of organizations don't test their backups frequently enough. I did mention a couple of terms there. One is immutable, other one is air-gapped ones. So let's see what are those mean for. So the immutable backups are write once, read many, like WARM model, applied to backup data provides immutability to recover from accidental or malicious deletions. Once data is written to a WARM compliant backup system, which is write once, read many, it cannot be altered or deleted. This immutability is your first line of defense against both accidental deletions. And the next one is air-gap walls. So this air-gap walls is the key to secure backups. The immutability alone isn't always enough, like what we talked about just before. So we did say that this immutability is your first line of defense, but it's not just always enough. With the recent threats, technology, or sophistication that what is going through these ransomware, we need to take it to the next step further. That's where the concept of air-gapped vault comes in. So imagine a secure, isolated location for your immutable backup copies. This vault is logically separated from your primary environment, make it significantly harder for threats to reach and compromise your recovery data. With the air-gapped vault, the immutable backup copies are locked by default and further protected through encryption using service provider owned keys. It's not a custom managed or customer created keys. These are with the highest level of encryption like AES 256. Encrypting recovery points within service provider owned key not only safeguards against accidental or unwanted deletions of user managed keys, but also reduces operational overhead and key management costs for users. The logically air-gapped vault simplifies sharing backups for restore purposes across accounts using Resource Access Manager called RAN. So customers can share the vault data with the specific accounts, including cross-organization, cross-region, for faster direct restore. Once the vault is shared, the backups can be directly restored, removing the step where backups are copied to the destination account first. This reduces the operational overhead, time to recover from a data loss event, and cost of extra copies. These vaults can be configured in a couple of modes. So one is governance mode and compliance mode. So what is the difference? Like what is governance mode and what is compliance mode? Governance mode is intended to allow a vault to be managed only by the users with sufficient IAM privileges. So that means specific level of administrators can only administer them. So vault lock is deletable if needed. So all the recovery points in the vault are locked and cannot be deleted until the lock is lifted. So that's the governance mode. And the compliance mode is a little bit different. So this is designed for backup vaults in which the vault is expected to never be deleted or altered until the data retention period is complete. So when a vault is in compliance mode, is locked. The lock can't be changed because it's immutable. No one, including the root user or your service provider, can manage or remove it. However, you can define a grace period, also known as cooling off period, before the vault locks and becomes immutable. The only method to remove the lock is to terminate the account. However, doing so also deletes all your previous backups. If needed, accounts can be restored from cloud service providers within some time limit. So example, AWS, if your account is getting deleted, then you can always restore it back within the 90 days. So that's ample amount of time. And then implementation tip. So AWS Backup and Google Cloud now offers logically air-gapped vaults that are immutable by default with compliance mode vault lock. These vaults support cross-account sharing with the Resource Access Manager and use service-owned KMS keys to protect against key compromise. Along with these two providers, there are other custom providing solution providers like Veeam, and then there's other one, Elastio, there's a Red Bear. So there are multiple vendors who supports these kind of air gap vault solutions. And then moving on, so let's move on to the advanced backup architecture. So let's discuss how to implement a ransom resilient backup architecture. So if you look at this, so before I go into the architecture diagram explanation, so I'll just do a little bit approach so how this is approached to recovery architecture. So it's a multi-layered approach. In the security world, there is a concept known as defense and depth. So let's take a very similar approach in terms of making it harder for bad actors to be able to compromise backups. But defense and depth, similar to the analogy of castle, like a medieval castle where you have multiple layers of defense. You will have a moat filled with water, you'll have big caves, a big approach is no different in the security world. So you want to make it as hard as possible for the bad actors to be able to achieve those objectives. So implement a local backup vaults for operational backup needs, create a logically air-gapped vaults in dedicated accounts to store immutable backups. So implement these logically air-gapped vaults for multi-cloud environments as well. So you can apply that for both the multi-cloud provider or standalone cloud provider. Design a cross-region vault architecture to provide protection against regional disruptions. So we do want to specify this because if you are doing the backups in the same region, when it comes to the disaster recovery, if something happens in that region, could be natural disaster like floods, fires, earthquake, anything. So this will really help you. So this will serve the both purposes, disaster recovery as well as the ransomware backup and recovery. And then establish a clean room, so which is like a new account for data validation from the air-gap vault. So if you look at the diagram, so here, so I have the main production workload accounts, which is in region 1. So I have all these different type of workloads, starting from object stores, block storage, like computing resources, relational databases, NoSQL databases, or graph DBs or DBs. So all these are being locked or backed up to a local backup vault. So this local backup vault is being encrypted with either a customer managed key or a service provider key. So this will help you in case of any operational purposes. Say you have some issue happen with your database and you want to restore the yesterday's backup or right before the snapshot, right before that incident. So not related to the security incident, but basically any operational incident that happened internally. Or some deployment happened which corrupted the data, so you want to roll it back. So in those case scenarios, this local backup vault will help you. Next one. So we are designing the air gap vaults to be in a dedicated account. So that way, even if your primary account gets compromised, you don't want the attacker to be connected to your air gap vault account. So that way, your air gap vault account is completely isolated, cannot be reachable, neither through network setup or your organizational network or production network to the dedicated account, because you don't need a network access kind of thing. So it can be either in the same region or cross region. So for instance, for demonstration purpose, I showed it here as a region 2. So that means we are calling this as a data bunker account. So where you will be saving or centralized account to manage your air gap vault backups. This one is being guarded with a service provider keys itself instead of your custom keys. So that way, even if something happened or attacker gain access to the account, he cannot do anything without the keys. So since it is not being created by customer or custom key, it's a service provider, which he cannot, it's impossible to gain the access for the key. So that makes it more harder for the attacker to even touch the air gap vaults. So even if the account access being compromised, the backups are immutable. So it cannot be touched or altered or tampered. So all they can do is delete the account. So even if the account is being deleted, we just talked about it a little bit before, the accounts can always be restored within after some days or within a few months. So that way you still have a chance of recovering your data. And then the next crucial point here is you have the backup account, data bunker account where you are keeping your backups. And then if the incident happens, like if the ransomware attack happened and there is a need to restore your air vault backup stuff to your account, we don't want to do that back to your primary account, like production account again back, because you never know, the attacker still may have access to your network somewhere. So don't assume that. Assume that it is being compromised. So don't ever put back your restored or backups or restored backup solutions into the same account again. It will be compromised again. The attacker can get an access and then again repeat the same thing. So that's the first thing. So don't assume that it's been compromised. You don't want to go back to that account. And the next option is you create either you recover in the same backup account, or you can create a fresh account. So that way you can deploy them clean. So that way you are sure that attacker doesn't have any access. That's clean. Only you have access or your organization have access. Sometimes, even if there's assuming the backups are good is also a big mistake. So you need a security controls for your backup systems. So you need to implement multi-factor authentication for backup system access, use role-based access control with principle of least privilege, enable geofencing to restrict access from specific IP ranges. Because to access the backups, you don't need everybody doesn't access your backups. So only the administrators or corresponding teams only do that specific job. So you can restrict that through the geofencing. And set up detailed audit logging for all your backup system activities. That means when these backups are being done or initiated or completed, so make sure these actions are being logged. So that way you have a trail log. And then deploy anomaly detections to identify suspicious backup behavior. In case you want to make sure if somebody trying to tamper with your backup solutions as well, or backup systems or vaults. So you need to make sure you have anomaly detections enabled on these things to identify that kind of behavior. And also next thing is automated backup testing. So having backups, a backup isn't a backup until you have successfully restored it. So that means a crucial but often overlooked component is regular automated testing of your backups. So according to Gartner, 30% of organizations that test their disaster recovery plans find critical gaps that would have prevented successful recovery. So it's pretty important to have that kind of automated backup testing. So in this scenario, I explained or designed in such a way, you can either do the automated testing in a different account called a forensic account. You will be doing the backup restore and then to a actual resource type that which you want to deploy the data to restore to using that using the RAM, like resource access managers. You don't need to do a copy manually or anything. So it's easy with the air gap vault with the resource access manager management access. So you can simply give the access to a cross account or external account, anything that you trust. You can configure that policy so that your vaults are being access to your resource can be accessed to the backups. So once you restore the backups in the forensic account or in the same account, you can test that backup data. That you need to make sure that you validate data integrity, verify the recoverability metrics, and also schedule the regular test scores. So you do that, and then you can also add an additional step on top of it, like a scanning. Scan your data that you restored. So that way your data is clean, malware free, or any kind of ransomware kind of malware. So that way you can set up alerts if something like the automated backup testing completed successfully or not. So that way you will be informed. And if it is something happened, you have a way to track it and then pay immediate attention to that step or alert. And then automatically clean up the test resource. So once you're done with the automated backup testing, you need to make sure you clean up your resource because this gonna incur costs if you want to keep them running, because it's just not a one-time iteration. It will be keep happening every day or based on how you schedule that kind of backup validation. It could be weekly ones, daily ones, monthly ones, something like that. So make sure you document results for compliance purposes. And then the last one is, how do you recover? So in case of actual incidents happen, now you have all these precautionary steps all in place. You have the air gap vaults, you have the locked vault logs, you have the KMS keys, service provider KMS keys, you have the restored automated test backup testing capacities, including the scanning of the restored resources or data and the data integrity validations. So all these steps are already in place. So now it's a one-step thing that you can restore your data in case of actual incident. If some attack happens and you cannot use your primary production environment, you can simply create a new recovery account or clean room and then provide the resource access management access through the RAN, through your backup air gap vault to the new account that you created. And then you can restore the backups straight. You don't even need to copy the backups from the air gap vault account to the new clean room, because that's the beauty of air gap vault log. So you can just assume that role and then deploy it or restore into your new clean room, and then your applications, all your data is being restored and ready to go. So that's a design of a ransomware recovery architecture, how you can implement. That's effective enough. And then as I mentioned earlier, restore testing is a critical piece that you need to consider. So most oftenly, this is being overlooked. Backup restore testing can assess recoverability of your business data against data loss events and prove the recovery posture for compliance using custom-defined resource testing plans. Because sometimes organizations do have different kind of compliance that they need to follow depending on type of industry they are in, financial, healthcare, kind of things. So this will really help in managing that posture, strong periodic restore tests, the supported resources that's been backing up. This will give you a much confidence on restore capabilities. And then moving on to the next section, which is what factors impact the cost on these backup cost associations, on backup cost factors, you can say. So there are 4 areas like scope, how much data needs protection, and then frequency, how often should backups occur, and then retention, how long should backups be stored. And then the last one is copies, how many redundant copies are necessary. So based on these things, your cost can vary. So if you look at here, so they did the resiliency options that you want to choose in the cloud environments. So usually the backup and restore, that's a least cost associated because your RPO and RTOs typically in hours. And then the pilot light, which is like a ready to go, but it can take a little bit. Recovery point objective can be minutes and recovery time objective is hours. So that means your data is within the tolerable time, like a few minutes, but your restore time is within 1 hour or 1.5, 2 hours, something like that. And then the warm standby, this will increase the cost as well because you are almost maintaining a secondary kind of setup or environment, but you will get a good RPO and RTO in minutes, but the cost will be much more. And then coming to the last one, active. Traditionally in the on-prem infrastructures, architecture kind of thing, used to have active, like we used to have an active data center and then the disaster recovery data center setup where you have the global load balancers for every application. If something goes down in one data center, automatically the other one will pick up and the traffic will be routed. So it's like within seconds, you won't see any customer impact or anything. So it's within seconds or within real time, your RPO and RTOs are close to real time, and then cost is much more because you are paying twice your production environment. So that you should be wary of. And then coming to cost optimizations or use cases. So where this majority of your data been sitting in your environments. Majorly, you have three kind of storage places where one is a block storage. Something like if I want to take analogy of AWS, like it's EVS volumes, like ideal for high performance applications requiring fast access to data. And then the other one is object storage. These are best for unstructured data and large scale storage needs like logs or anything. So this is something related to, you can analogy with S3 in AWS. And then the other one is relational database or the non-relational databases. This is suitable for applications needing complex queries and transactions. Typically, this is like your RDS in AWS. It could be anything. It could be MySQL, Postgres, MS SQL, or even the NoSQL, MongoDB, Cassandra, or something like that. So these are the usual cases where you will be placing or holding your data onto. So based on how your application is designed. When it comes to the automation best practices, since we know what kind of cloud storage that you are using for your use cases, based on that, we can derive the cost optimization best practices. So in terms of block storage, so this is especially like block storage, something like EBS. Know your change rate and projected growth. So you know how much data you'll be accumulating or what is the growth that you projected accumulated data. And retain backups only as long as needed because this could cost you a little bit more. And use cold storage when appropriate. So if your data is not in operation, that you just need it for some kind of rare usage, you can use a cold storage. So that way you can reduce the storage cost for especially related to block storage. And then the object storage. So something like S3. So use continuous backups with periodic backups. Delete older object versions and clean up expired delete markers. Adjust backup retention and copy frequency retention if needed, because those are the few ways that you can optimize your costs in the object storage class. And the third one is database or relational database storages. So you can leverage free backup during continuous backup retention periods. Some providers offer these kind of initial free backups, and then you only keep backups past continuous backups. Factor in backup copies costs because based on your database size, you can incur a lot of costs when you want to have more number of copies. So that will impact directly to your cost associations. Access and understand your current cloud backup costs because you can assess what is your current storage costs are, cloud operation costs are, and then what kind of backup solution that you are planning. Like we just discussed a couple of architecture styles or architectures that can foolproof ransomware readiness. So these will give you a little bit more understanding on your backup costs. Implement lifecycle policies to automatically move older backups to lower cost storage tiers while maintaining appropriate accessibility, because you don't want to have these ever-growing storage needs on a hot storage. So you can go for infrequent access or glacier storage, something like that kind of things. So that can reduce your storage costs, especially related to the cloud optimizations or cost optimization best practices, especially related to the storage. So moving on, building a ransomware incident response plan. So despite your best efforts, a ransomware attack may still occur. So therefore, it's essential to have a robust incident response plan in place to minimize the impact and facilitate a swift recovery. So you need to, there are a few areas that you need to focus on. So define roles and responsibilities. So you need to make sure, establish a cross-functional incident response team, clearly define who makes critical decisions, include technical, legal, communications, and executive stakeholders, document backup escalation contacts for each role. Believe me, these things will help you a lot when you are in a real incident. And then create communication protocols. So when things get seized, you don't have a way to communicate in a normal organization. The communication channels can be down depending on what type of incident happened, on the type of ransomware attack happened. So it could be your administrative tools or platforms got encrypted or systems impacted. So in those cases, you don't have a way to communicate in a regular way. Instead, you should create your communication protocols in case if something happens. So establish secure out-of-band communication channels. Develop templates for internal and external communications. Include notification procedures for regulatory requirements. Document contact information for law enforcement and third-party experts. Document recovery procedures also important because you need to create a step-by-step recovery playbook so that you know who needs to do which parts and what are the sequence of steps. And you need to include decision trees for various attack scenarios and document restore procedures for immutable backups. Maintain up-to-date system configuration documentation. So these things, excuse me. And then the last one, practice regularly. This is the most oftenly overlooked item. So until unless you test your backups and they're valid, you cannot call them backups. So you need to practice these regularly. So conduct tabletop exercises quarterly, run full recovery simulations at least annually or semi-annually, update procedures based on exercise findings, involve executives in practice scenarios. Remember that in the heat of incident, documented procedures are invaluable. The National Institute of Standards and Technology reports that organizations with documented incident response plans resolve incidents 40% faster than those without these plans. So coming to the end, so I'll just do a few conclusion and key takeaways from this session to wrap up today's discussion. So let's emphasize these critical points. So ransomware is evolving and inevitable. So it's not going away. So it's not a matter of if, but when. So that threat landscape continue to evolve with attacks becoming more sophisticated and demanding. So it doesn't matter what kind of if left kind of strategy that you follow, predictive or proactive or detective kind of tools that you implement or technologies that you have, the scale that it is evolving, the ransomware is evolving, the threat landscape is abnormal. So that the sophistication is also extended recently with the AI introduction. So for sure it's not if, but when. And then backups are your last line of defense. So believe me, but only if backups are properly protected, tested, recoverable. Adopting the 3-2-1-1-0 rule that we talked about, zero trust ransomware architecture and immutable backups provide a solid foundation for ransomware resilience. And the third one, recovery capabilities must be tested. So untested backups often fail when needed most. So regular testing is essential to ensure your recovery capabilities are functional. And preparation reduces impact. So organizations with documented and practiced response plans recover faster and experience less financial impact. And then the last but not least is incident response requires cross-functional collaborations. So the technical teams, executives, legal communications, and other stakeholders must work together tirelessly during an incident. So I would like to close with this thought. Ransomware readiness isn't just about technology, it's about people, process, and preparation. The organizations that handle ransomware incident most effectively are those that have invested time in planning, practicing, and preparing before an attack occurs. Thank you for attending today's Conf42 conference. This session is useful for you and your organization. Thank you.